This is FarmOS, a 3D farm with AI analysis and action for weeds, pests, and soil. So the problem. Every year, 40% of global crops are lost due to anomalies such as overgrown weeds, pests, sprinkler faults, and soil issues. And crop yield failure is expected to increase by 4.5 times by 2030. Why is this? It's because currently, scouting for these anomalies has to be done in real time manually, a farmhand walking through the fields. In addition, with 11 billion acres of farmland worldwide and an increasing farm labor shortage, a farmhand might miss detecting an anomaly. But what if a farmhand could digitally traverse the field over and over again to inspect it before stepping onto the field to take action? And what if an AI agent could do the same with a 3D version of a farm?
Let's jump right into the demo. From the FarmOS dashboard, we first see three things: our agent logs, our 3D Gaussian splat, and our weather conditions and weather report of the total field. In our agent logs, you can see the most recent actions of our AI autonomous drones, but let's see what that looks like in action. Here, a drone spotted a weed cluster, so let's have it take action. It's going to go over, inspect, and take care of that actual weed. Now, let's look at the overall report for the health of the field. Here we can see overall summaries of how our field's doing in our vineyard and see a nutrient balance score from fair to good. But let's look at the 3D view and be able to actually immerse ourselves into the crop view of our model. Here we can walk around our actual farm crop row, and from here we can see where our AI has actually picked up where the weeds are on the field and clustered them into an easy viewable space. But let's go into our soil analysis. Here you can see all the minerals in the soil and be able to view that in a heat map of a specific mineral. So here we're viewing nitrogen, and all of our markers have information about the nitrogen in that particular region of the soil. And it's important to note that this is an actual map of the Gaussian splat, and it's a heat map over it. So these are the actual crop rows that are planted.
The biggest technical challenge in this project was taking a 3D space in the Gaussian splat and getting AI to be able to see it, and then converting that back into 3D space to figure out where the weeds actually are. So to do this, we created a simulated drone path through the splat to take pictures of the crop rows. Those frames are fed into Gemini to first detect where the soil is. Then we feed those pictures of the soil for Gemini to look at the weeds. Then using the saved 3D coordinates from a simulated drone, combining with the pixels where Gemini said there were weeds, we can create markers in 3D space and eliminate those weeds via drones. Our tech stack was pretty simple. We had React in the front end and FastAPI in the back end. We used Google Gemini 3.0 Flash as a multimodal model and can read images really well. The future of farming is here now. It's with drones and AI. Right now, we can take a video, upload, and get a weed map, but soon with autonomous drones, we'll be able to take care of weeds, fertilizer, moisture, everything, and the farm will run itself.